Hello and good morning to our talk about how we are doing openSUSE enablement for framework laptops. And first of all, I have a simple question. Does anyone already have a framework laptop here? Not yet? Okay. So no framework users yet, but I hope we can convince you to buy one because we think it's a really great product and we hope to get more openSUSE users on it. So first of all, who are we? My name is Nico Krapp. I am a Linux engineer packaging at SUSE. So I'm working in the packaging team, mostly at Python packages. I'm one of the maintainers of the Python ecosystem in openSUSE, which means like all of the packages in the Devil Languages Python project. You can find me under the username Tilting Penguin on GitHub and also on the framework forums, since it's...
And I'm Marvin Friedrich. I'm an apprentice at SUSE, and I work mostly with hardware and, for example, RISC-V. You can find me on GitHub and in the framework forums.
Okay, so what are we actually going to talk about today? You can see I want to mention a bit about the background of framework, since not everyone might be familiar with it. We're going to talk about the upstream work that framework already did to enable Linux. Some openSUSE specific things that we already did and are working on. Then I have a small section about packaging, the software that framework has for their laptops that I've packaged. Then Marvin is going to talk a little bit about how laptop enablement works in general, and especially with the RISC-V mainboard that has been released for the framework laptop 13. Then we're going to jump a bit in the future to talk about the framework desktop and framework laptop 12 that are coming out. And the last section is about getting openSUSE on the list of officially supported, community-supported distros on the framework page. So what are framework laptops actually? You can see one here. This is my personal framework 16. Framework makes modular and upgradable laptops, which is really great for a lot of Linux folks who like to tamper with their hardware a bit. What really makes them special is that you can replace every component of the laptop yourself, and they offer the parts and they offer guides how to do this. Like everything from the screen to the main board, the keyboard, literally everything. Framework is also special in the regard that they are very friendly upstream for Linux. They put all their drivers for the hardware. I mean, it's they offer Intel and AMD based chips, so it's not that much work. But all of the hardware has upstream support in the kernel, so every distro can basically already use them. And which means that openSUSE just boots right out of the box, and we don't need to do any enablement, and that's the talk. No, while it might work out of the box, there are still some small things that we can do to make the experience even better on framework laptops. So. Yeah, like I said, most things just work. You can boot, you can install openSUSE, you can use any desktop you want. Everything is just fine, except that, which isn't an openSUSE specific problem, but fingerprint sensors are a bit finicky under Linux, so we need to set these up ourselves. Just requires a few commands, and it's actually not that hard. We do have a guide. As you can see on the bottom, we have a guide in the openSUSE wiki on the HCL framework laptop page, where we documented everything from known issues to installing and every feature you can use on the framework laptops. And one thing I want to mention, which is a bit of a leftover from the last time I did this talk, earlier this year we had a problem with Mesa 25 and the kernel 6.13, which was an AMD GPU problem, so not even exclusive to framework laptops, but a lot of framework users suffered from it, where you could get some artifacts on your screen. This is now solved. On openSUSE, you could either use the kernel long-term package, which would fix this problem, or since the 6.14 release of the kernel, this has also been fixed for everyone. So about the packaging, this whole thing started a bit out as my Hack Week project last year, where I wanted to package all of the framework software in the OBS for all openSUSE people to use. I needed to make a bit of a decision between if we wanted to also package the firmware for some microcontrollers that they have in their products. But in the end, we decided to not do this and instead offer the firmware via FWAPD. And I noticed the image is broken, great. So the first software I want to mention is the input module RS, which is a Rust software to manage this microcontroller that you can use on framework laptop 16s. Most commonly, this is the LED matrix, which I will show in the demo later. So you can use this Rust software to interact with it and do fun stuff on a microcontroller. It also has a Python API, like you can use the Python GUI or the Python API with Pygame to even build your own software on top of it and have fun things to display next to your keyboard. You can see at the bottom, these are the packages that you can install for that. I've split it into different packages, and I know the naming is not the best, but yeah. Then there is the Qmk HID package, which is not even just for framework laptops. It's just basically an API to interact with a Qmk keyboard. So you can use any Qmk keyboard with it. The laptop 16 has one, so you can use it to control the backlights or the RGB if you have an RGB-enabled keyboard. Yeah, and you can see there's also a Python GUI for that, and you can install it in 2 simple packages. Then there is the upstream, the repo is called Framework System. It's packaged as Framework Tool. It's a CLI to interact with a lot of low-level features of the framework laptops. They all have a so-called embedded controller in them, which you can speak to and do a lot of things that you could usually only do in the BIOS, like like battery control, setting a battery charge limit, something. This one has seen a lot of progress in the last few months. They worked really hard on it to enable it for Framework Laptop 12 and the Framework Desktop. So now the current version should work with both of these, though I haven't been able to test that yet. So then we have the Framework Laptop Kernel module, which is a community project. It's not offered by Framework themselves. Someone in the Framework community wrote it. Our third team member for the Framework enablement team, Tobias Goggins, packaged it. You might have seen him yesterday with his Yuga Linux talk. Yeah, and it's basically a kernel module to expose the LEDs and battery charge limits specifically. So you can also use that to play around with these. And last thing is the Keylight Demon, which is also a community project, also packaged by Tobias. And it's just a simple daemon that exposes the backlight of the Qmk keyboard, or not just the Qmk keyboard, also the Framework 13 keyboard. So you can have a systemd daemon that controls it and sets the brightness automatically. So one section I forgot in my last talk and was asked about is what about leap support, because most of the things I've talked about is very Tumbleweed specific. Leap 15 is very hard to support for us because the hardware of the framework laptops is really new. And also some of the software requires very new versions. Which means Leap 15 is not really supported, and we can't really support it. But we want to support Leap 16 fully. And we started working on that, and it should be just as a smooth experience as Tumbleweed is. Okay, so Marvin is going to tell you about laptop enablement and
No, skip one.
Oh, skip one. No. Oh, great. So we're missing a slide, but yeah. So Marvin is going to tell you about how to support a laptop in general and what the RISC-V mainboard, what work has been done there.
All right. So usually when you start working on a new device, especially in the context of openSUSE and Tumbleweed in this case, first you have to identify what hardware do you have. Is there any new hardware, any drivers that that are not packaged yet, that are not enabled in the config for the kernel, that are not, in the default image of Tumbleweed, so where you might have to do some patching. Then you have to identify the user space components, for example, Mesa, which needs an equivalent for the kernel module. And those go hand in hand, and then you have to kind of make sure they all align, they build stably. You have to test everything, that everything works fine. And it's a whole big process that you have to do in basically every kernel iteration. And this is actually pretty easy on traditional laptops because you have UEFI and ACPI, all these technologies that come together and automatically basically do all the work that you need to do for the enablement. This was kind of a challenge for the deep computing mainboard. If you don't know, the DC Roma is a third-party mainboard, I would say. It's not made by Framework. It's made by a company out of China. It doesn't use an x86 processor like classic, like almost every PC has nowadays. It uses the RISC-V instruction set architecture. If you don't know what RISC-V is, it's basically an alternative to x86 or ARM, which is completely open source as in the specification. The actual silicon, the SoCs, may not be completely open source, but there are open source SoCs, so this is a huge benefit. It's relatively new, and when I say new, it's been out for 15 years almost now. But we're starting to see more and more hardware, like, for example, the RISC-V mainboard for the framework that features the RISC-V ISA. So it's a pretty young ecosystem. In this case, it's based on the Star5 Vision 5.2, which is like the most sold, I would say, RISC-V single board computer up to date. So kind of like a Raspberry Pi. The problem is that because it's not a traditional PC, it has neither UEFI or ACPI firmware. So that makes it so much more challenging to get it enabled. It requires U-boot, which is basically, it's similar to EDK2, which is a UEFI-like firmware. It provides some functions, for example, for the Linux kernel, to boot, in this case, in a standard way. Because if you don't have that, you basically need an image for every single device that you enable. In this case, it needs device trees, which is kind of like a config file that describes what peripherals the device has, at which memory address, where the RAM is, for example. And this makes it so challenging. And you can also see the upstream support for this board is really bad. It's the biggest thing you want in a laptop, for example, is seeing things on your screen. That doesn't work yet. So there's a ton of patches by the vendors, in this case Star5, to basically give you an image. And that means you cannot boot regular Tumbleweed. We do port. So if you go on get openSUSE.org, you usually see like x86, ARM, I think PowerPC and S390. But if you go on download.opensuse.org, you can actually see the RISC-V port. So it's not the highest priority, which doesn't really help our case in this case. So we will have to build a custom image that has all these kernel patches for now, enables all the extra config options for the non-standard GPU, unfortunately. And that's still going on right now. It does boot with a custom kernel that, is basically handwritten at this point. And we're trying to enable, of course, everything that has to do with the framework laptop. So we're still having putting some effort into packaging everything, and then actually providing a usable image. It's kind of work in progress, but you can expect this to be available at download.opensuse.org. It'll be in one of the ports folders if you go in there, and you just flash it, for example, to an SD card. Because the mainboard doesn't have an NVMe slot or anything like that. It just has a tiny micro SD. So you boot off that. It's not very fast. It's meant for, like, if you thought of buying this because it's cool, it is cool, but it's also really slow. To boot into GNOME, for example, it takes like 5 minutes. So be warned, it's meant for developers and people that actually want to bring the RISC-V ecosystem forward. But yes, we will have images at some point. I don't know when that will be, but in this lifetime for sure.
Okay, so, and there's the hardware enablement procedure. Okay, great. I swapped some slides. What about the future? So what are we still working on? Mostly the new products by Framework, which is the Framework desktop. Like a small PC in a 4.5 liter case, which is really, really powerful machine. They're advertising how powerful it is with AI usage, for example, and also the Framework 12, which is a little bit cheaper, more on the target audience for students, which can also convert to a tablet. Which are both really exciting projects, and we will enable them for sure when they come out and we can get our hands on them. That's it from the framework side. But of course, I said we want to be an officially supported community distro. This will be coming soon. We are in contact with the framework people. The communication is taking some time, but we are definitely on a good way. We are fulfilling all the requirements basically by now. So we might even get some testing hardware. And like I said, the Tumbleweed is for now the priority. We will try to get a community support badge for Leap as well, for Leap 16. But I don't know when that will be yet. So and now I want to show you a little demo, and I hope this works as I expect it to be, because I actually brought a webcam here. Oh, yeah. Ooh. Yeah. Okay. So here you can see my shitty webcam and the LED matrix, and like you will see it a bit better in a second. But this is basically it. You can see it's like a 9 by 35, I think, LED screen, and you can do lots of fun things with it, like display strings and play some small games. And so, okay. So the first thing I can show you is the framework tool. Yeah. And you can see it has lots of options to do lots of different things. You can use it to control some of the BIOS things for the microcontrollers. You have fan control in there. You can do power delivery settings. You can interact with the embedded controller. Like I said, it can dump the flash it, and everything. Yeah, it's a really great tool to control like every framework-specific aspect of the laptop. And yeah, I can do a test run, a small test run. Some of the options require sudo, but yeah, as you can see, the test ran through. In the beginning, when I first tried to package this, it was a little bit broken, and you couldn't really get a connection to the embedded controller. But this has been fixed now for a few months. So, the second thing I want to show you is the LED matrix. And you can see it also has lots of options, what you can do with the LED matrix. You can set the brightness of individual LEDs, you can animate stuff, you can display a small image, and it can even stream from your webcam, though that isn't really useful with a display of like 9 by 35. Yeah. Okay, and it can also have like a equalizer, and yeah, it can play some games, which I will show you in a second. But first, let's do an. And you should see it here, and it will just display some random equalizer stuff. Like I said, there's lots of different options to control this, and you can even program it yourself to display whatever you want. For now, I will just see. Nope. One of the issues with this string display is that it can only display uppercase letters, which you can see because there is now just question marks there. But it can display OSC if you actually put it in caps. So one more thing I can show you is the games, which is, for example, Snake. And like I said, the base module for this is the input module control, which can also control some other microcontrollers that are not really out yet by framework. They're more like a proof of concept. But what it can do, what you need the Python module for, is to actually be able to control the game, like I'm doing here. If you do the Rust CLI only, then you cannot get input for the games. Just yeah. So what else can I show? There is a funny clock actually, which I like a lot. For example, 10, and what is the? Oh yeah, okay. Yeah, it can display a clock, which updates itself. What I meant to do was the timer, which is a bit. What is it? Oh yeah. You can show a different percentage, which might be useful if you want to have like a screen showing, hey, my build is X% done. And also, is it? What's that? Oh yeah. I think we still have some time. And okay. Yeah, but what another thing I can show you is the GUI. No, GUI. And it's not the prettiest, but in the beginning, when they first released this, they used a Python library called PySimpleGUI, which has since switched to a non-commercial license, which means I couldn't package it for openSUSE like that. Thankfully, someone from the framework community made a patch to just use the built-in Python GUI. So it's not the prettiest, but it does work. And for example, when I show you the dynamic, yeah, exactly, the countdown timer. And you can see it slowly fills up the LED matrix like this, instead of just displaying the time, the amount. Here you can also have another game, which is LED Riz for I guess copyright reasons. Yeah, and you can see on the top there is the score, and there is also there should be a representation of this of the game on the screen, but it doesn't seem to really work right now. Don't know why. Yeah. So if you're really bored and you have a framework laptop, you can just play Tetris on the side of your keyboard, which is a fun pastime. I hope it's somewhat visible here. I think like with the it might be a bit too bright for the camera. Actually, I can try. If I quit this and quit the GUI, could maybe fix this by setting the brightness. Set brightness, right. Brightness, yeah. 2, and let's do brightness 100. Okay, not too much better. 50. Is it getting better? I don't really know. Ah, this looks better. Now you can actually see something and not just watch some weird LEDs blinking. Yeah, so one more thing I want to show you is the Qmk interface. You can see this is just the keyboard with some backlights on, and I can use KHID to see like yeah, it does have a VIA interface. I think it's still work in progress. It's not completely working, but in theory you could also use this to enter VIA, which is a control software usually in the web browser, which you can use to remap every key on your Qmk keyboard, which can be really helpful. But what I want to do is the Qmk -c. So this is the Qmk interface. You can see it has all the key presses and a programming interface basically, and how to use it. And the moment I press something, it logs all the data. But which I think that might be a bit easier to use is the Qmk GUI. Yeah, there you can see the device that is actually attached. If you take off your keyboard for some time, you might need to reconnect to it. It can do firmware updates. Not right now, I guess. I think my keyboard should be on newest firmware anyway. And yeah, I don't have the RGB keyboard, so yeah, I can set the brightness. If you can see it updates pretty well, but I sadly cannot do show the different colors. But there's also this breathing effect. Yeah, it's a nice thing to play around with, and it also has the program interface to make it do whatever you want. Yeah, so I think we still have some time, but yeah, but I think we don't have too much more to show actually. We just get the and the QR code doesn't work great. Should be a QR code to the slides. You can find them on my GitHub. I have a talks repo where I uploaded the slides, so you can also see all the links I put in and follow the links to the different upstream projects and to the images for the RISC-V mainboard. Are there any questions?
Thank you. For the framework laptops, what is the target audience? Is it makers, or is it people just want to repair their stuff, or do they want to go for end users?
I think it's really all three. Like obviously, as a maker, you can have lots of fun with the framework laptops. In that case, I would probably recommend the framework laptop 16. But like the framework 13 is really popular with all audiences. Like if you want to have a laptop that will live a long time, that you can replace the mainboard over and over again, so it basically lives forever. That's a really good use case, but it's also just a really solid laptop on its own, even if you don't plan on taking care of it forever or tinkering with it.
So in the x86 world of laptops, particularly low-cost laptops, there's always sometimes a problem where suspend doesn't really work or something else doesn't work, and if you go down that route, you maybe find that there's a problem with some stupid ACPI tables made by the manufacturer. Have you had any similar experiences where a function doesn't work or is outright broken from the factory?
I haven't. There are people that have. Like if you look in the framework forums, you will find some people who had some problems, especially with if they pre-ordered it and got one of the earlier batches. But framework is really dedicated to fixing these problems, and if you report them upstream, they will take care of it. Like for a lot of the issues, like even hardware issues, they send you free replacements, or which you can then change out yourself, obviously. And also they are updating their BIOS and everything. So yeah, I haven't had many problems that aren't also like Linux problems in general on most laptops. Yeah.
On that point, I actually looked at the ACPI table dump. I disassembled the AML code. It's very clean. If you ever looked at other vendors' ACPI implementations, they're not very clean. A lot of missing functions, broken functions, errors. It's done by Inside, as far as I know. So it's not actually done by Framework, it's outsourced. But it's very good. I can only attest for the Framework 13, for the 11th gen Intel board and the Ryzen 7040 board. Everything works, sleep, hibernate. As far as I know, there's nothing that's really broken. It has a lot of tables, let's just say. There's like, I think, 20 DSDTs. But all of them are really well put together. No bugs as far as I can tell. And they're not just made for Windows. They're always made with Linux in mind. So in that case, I wouldn't really worry about it.
One thing I can mention, which I was a bit ticked off about, is the Wi-Fi chip. They have a MediaTek Wi-Fi chip in all the AMD-based laptops, which does not have great Linux support, and I've had some problems with it. But in any case, you can just swap it out for an Intel one. They even offer one on their site. You can order it for, I think it's $20. So yeah, if the MediaTek chip might not be really good, but you can swap it out. It's sadly, like, I think it's a requirement by AMD to put in the MediaTek Wi-Fi chips for AMD-based laptops, so not really something they can do something about. And also, here you can see the link that should be on the slides. I put the slides in PDF and HTML form.
Hey, I had another question actually. You packaged quite a lot of stuff. Do you plan to make in, for example, a Gamma or whatever installer to automatically recognize the laptop or provide images or something else?
That's a good question. Right now, I don't have any plans to do that. I might work on providing a custom image for Framework laptops, but on the other side, I like being able to mix and match the different parts of openSUSE. Like I'm running system deboot on this laptop. So yeah, I don't think there is that much of a use case for that. Like I said, just installing some packages, which I would recommend you just do after setting it up. You might not even want all of them, like the LED matrix stuff is Framework 16 exclusive, so it's not even useful on Framework 13s.
Thank you.
Does the LED matrix also show colors? Because there was a setting in the command line interface.
There is an option for that. It's not actually a feature of the LED matrix provided by Framework, but there was a community project to build an LED matrix which can show colors. So yeah, that one can do it, but it's a community project, and you would probably need to. I think the designs are open source, and you could build one yourself, but it's not in the default one. Okay, looks like time is up, so thank you for listening. And yeah, if you have any other questions about Framework, you can come talk to us. Thank you.